Where would we be without lists? Lists are just so handy and we use them every day for all kinds of things. So, of course, in processing, we also have lists. But in processing, they go by a different name. They're called arrays. And this is just a term that comes to us from computer science, but the word array means nothing more than list. In this video, I'll give you an overview of how processing thinks about arrays or lists. And then in further videos, we'll get into the actual mechanics. A great example of an array is a track meet. Here we have a number of lanes, and in each lane there is one runner. To identify where each runner is, typically we number the lanes. And so on the left, you can see the lanes are numbered 1, 2, 3, and 4. And on the right, runners often wear numbers so that they can be quickly and unambiguously identified. So we can look at any given track meet and say, oh, runner number 204 is in lane 1. Or we can ask, who's in lane 3? And the answer is number 466. So we can write this down in a little table like this that tells us which runner is in which lane, or we can represent it graphically with a little drawing. And so here I have 4 boxes, one for each lane. The boxes are numbered 1, 2, 3, and 4. And in each box, we have the number of the runner in that lane. This little picture in the bottom right really captures the idea of an array. In processing, an array can hold a list of any kind of data type: integers, floats, colors, booleans, whatever you want. But it is the case that each array can hold only a single kind of variable. So you can have a list of integers, or a list of floats, or a list of colors, but you can't mix them up inside the array. If you want to have a list of colors and a list of integers, well, you make 2 lists. So let me show you an example of this in action. Here is an array in the bottom half of the screen, which I'm representing by 6 boxes. Taken together, that's one list of 6 entries. And up above, I have 6 pool balls. I can take each pool ball and put it into one of the boxes. And so I can say the first box holds the value 1. In this case, my array is going to hold integers. And so each entry in the array has a specific integer. Now, I said that arrays can hold other data types, and they sure can. How about floating point numbers? Well, it's the very same thing. We can put a floating point number into the first box, or the second, or the third, or all of them. And now, on the bottom part of the screen, we have an array of 6 floating point numbers, one after the other. I said that arrays can hold colors, and they certainly can. So here's a little selection of colors, and we can associate a little swatch with each of these little wood panels, and we can bring out our array again. Now we have an array of colors. There are 6 entries, and we can drop a color into the first one and into all the others as well. So this is the basic idea of an array. We create a list of somethings. A list of integers, a list of floats, a list of colors, a list of booleans, whatever you want. And then you put values into the individual elements in the list. And now you can always ask a couple of questions of processing. One thing you can ask is, what is the value in any given box? And so I can ask in the top row, what is the value in the 4th box? And it will come back with 4. In the middle row, the value in the 4th box is 8.99. And in the bottom row, the value in the 4th box looks like a kind of a slightly yellow-gray to me. So we can put a value, whether it's an integer or a boolean or a float, whatever the kind of the array is, we can put a value of that kind into any one of the slots in the array. And we can also get that value back out. So it's like a whole big list of variables, but they're all kind of crunched together into one object, which is the array or the list. We can also ask processing how long the array is. In all 3 of these examples, the length is 6, but as we'll see later, you can play all kinds of games with arrays. You can make them longer, you can make them shorter, you can stick them together, you can take pieces out of the middle, and processing will always keep track of how long the array is, no matter what you do to it. So that's the basic idea of an array. It's just a list of elements. The only thing to keep in mind is the elements are always the same. It's either a list of integers or a list of colors, a list of booleans. Any given array holds only one type of data, but you can hold tons and tons of that kind of data. That's really all there is to the basic concept of an array. But once we've got this, we can do some wonderful things because we can start juggling around large numbers of objects that are related but different and create some very interesting graphics.